going to do an LU decomposition solution of the fundamental matrix equation AX equals B to the B vector -1, 7 and the A vector, or the A matrix 5, -2, 7, 1. Now, we've already been through the process previously, but without a specific matrix and without all the details of the solution. So we'll kind of review the process, although we did that in the preceding class and in our preceding video. So I'll review the process rather quickly and point out an embarrassing error that I made in writing this down. So here's our matrix. How do we reduce the matrix? Multiply the first row by 1/5. We do the same to the identity matrix and we get our E1 matrix, which when multiplied by this A matrix will give us a matrix with a 1 here. Okay? Then we would add -1 times this row of the new matrix with the 1 here to the 7, to the second row, so that we'd have a -7 added to 7 and get a 0 in the second column. And the elementary matrix that adds -1 times the first row to the second, we just add -1 times the first row of the identity matrix to the second, and we get this. So now our matrix A will have the form with the 1, 0 here and numbers here and here. And this is an upper triangular form because all of the elements below the main diagonal are zeros. Now in this case there's only one. With a larger matrix there'd be a lot more than one. We addressed that last time, so if you're not sure, look at the video right before this one. Okay, well it then follows that of course the elementary matrices are the matrices which when multiplied by this matrix or multiplied by any matrix accomplish the operation that we use to get the elementary matrix, and you should confirm that. So if we multiply this by A, we get a matrix, and if we multiply that then by E2, we'll get a matrix in this form. So that E2 times E1 times A is going to be a matrix like this, and this matrix is upper triangular. Follows that E1, E2, A, well, doesn't follow. Using the given matrix, E1 times A, you can verify it, gives us this matrix. And then E2 times that is, of course, E2 times E1A. That gives us this matrix, and that is an upper triangular matrix. So we verified that the matrix is upper triangular, and I believe I did that right, but check my arithmetic. Okay, so now we know that E2, E1A is upper triangular. Now, it follows then that if we multiply this, both sides of this equation by E1 inverse, E2 inverse, well, here's what we get. E1 inverse, E2 inverse times the left side equals E1 inverse, E2 inverse times the U matrix, which is the right side. Okay, well, why would we multiply by E1 inverse, E2 inverse? Well, it comes down to E2 inverse times E2 is the identity, and the identity times either E1 or E1 inverse is that matrix. So now we have E1 inverse times E1 times A, and E1 inverse times E1 is the identity matrix, so we end up with just A. Now here are some details. We can, matrix multiplication being associative, we can put parentheses around the E2 inverse E2, which of course give us the identity matrix. And then the identity times E1 inverse is just E1 inverse. So E1 inverse times E1, now I mixed these subscripts up. I wrote them down carelessly here, even though I'd written them down correctly here. And so I had to change them, so this yellow is a little maybe hard to read. But anyhow, this is going to give us E1 inverse times E1 times A. E1 inverse times E1 is the identity. Identity times A is just A. And then I'm just going to let L equal E1 inverse E2 inverse. That's going to turn out that E1 inverse E2 inverse is lower triangular. It has to be. We showed why last time. But I'll kind of allude to that. So right now I'm just saying whatever E1 inverse E2 inverse is, I'm going to call it L and hope that it's lower triangular. Well, we're guaranteed that it has to be because of what E1 inverse and E2 inverse are. They're both upper triangular. And when we multiply them, we get the lower triangular matrix, okay? And we confirm that. Here's E1 inverse, here's E2 inverse. We multiply E2 inverse by E1 inverse, we get this, which is not lower triangular, and I said it was going to be. So I'm going to have to stop and figure out what's wrong here. I've got them in the right order. There's E1 inverse, there's E2 inverse. So something's kind of seriously wrong here, so let me fix it.